Welcome, tech enthusiasts, to Rated, the place where we play devil's advocate to learn about the limits of technology. This is a sometimes heated debate where we argue whether a given piece of technology, tech platform, or software tool is overrated or underrated. I'm Nicholas Hughes, CEO of EITR Technologies, and I'll be your host on this episode, in addition to arguing for the side of underrated. On the overrated side, we have our guest, Natan Yellin. Natan, tell us a little bit about yourself.
Okay, so I'm a Helm chart maintainer. I maintain an open source project for Kubernetes called Robusta. I also run a commercial company, a startup that, in addition to the open source, has an enterprise software platform around that. But on the open source side, I'm a recovering Helm chart maintainer. We have a Helm chart. We use Helm. We love it. But there's some stuff that really annoys me sometimes about Helm, and I don't think it's always the solution. So very briefly, I'd say that Helm can't be underrated because it's just so damn popular. Like, how could something like that be underrated? The only thing it could be is overrated. And we should not argue. And that's it.
Awesome. Yeah. So our featured piece of technology is Helm. And so with your brief kickoff, on my side, I would say that it's underrated, mostly because I don't think people necessarily always fully appreciate what it is and what it does. There are a lot of people that end up using Helm charts just because they go to some application page and that's the deployment mechanism, right? Like, oh, you have a Kubernetes cluster, go ahead and run these commands and now you have it deployed, right? Like, they don't really understand what they're doing. They just know that like now they have this magical deployment inside of their Kubernetes cluster and it solves their problem for them, right? But the broad community support, it's all over the place. Like you said, everybody's really using it. It's pretty ubiquitous. There's a lot of things that it can do that can be really complex, that are hard with other mechanisms. Also it allows you to do really cool things with its version control, like updates and rollbacks and things like that. So we'll go a little bit more into the depths of things here in our main debate section.
So I'll tell you the problem, okay? The problem is that I'm a people pleaser, and I maintain a Helm chart. So like you said, people arrive on the Robusta GitHub page and they look over the docs and they say, okay, I want to install. And then they use the Helm chart. And then there's something really weird about their environment. There always is. I mean, not always, but like 0.1% of the time, but it's the big numbers rule, right? So you end up hearing a lot of these. And they have some unique special requirement. And then they show up in our Slack community and they say, okay, I'm trying to install with Helm and I have this issue. Can you fix it? And because we're people pleasers, we always do it. And we always add now an option to the Helm chart to support what they're doing. And that really one simple and elegant and beautiful Helm chart ends up getting really big and wieldy and complex. And I'll give you an example of that, okay? So imagine you're just deploying a Helm chart. You have one pod and you have two pods, let's say, okay? And you need one of those pods for a special feature. Like in our case, we have a pod that can reach out to Grafana and can send you like from Grafana periodic, like daily export of, or after a deployment, can send you like a bunch of charts from Grafana to see what's going on in your deployment, right? And it's a feature that's not used so much, so we disable that feature by default. So you don't even need to run that extra pod that knows how to like reach out to Grafana. So this is like a perfect case for Helm, right? You have like a flag in your Helm chart, enable it, disable it. Fantastic. That Helm is great for it. But now, like, okay, let's say you disable that. So now you're just running one pod and you have something special about your cluster. It's not unique to Robusta. And it's something that applies to all the applications in your cluster. Let's say you're, for cost-saving reasons, you have a cluster that's half irregular x86 nodes and half ARM nodes. You want to make sure now that like the Robusta pod doesn't run on your ARM nodes because it doesn't support it. Mm-hmm. Actually, we do support it, but we used to not support it. So this request coming on, right?
For the sake of argument.
For the sake of argument. So what do? So you say you open up a ticket on Robusta, you reach out to us on Slack, and you say, I need the ability to go and to add like tolerations and taints and stuff on like on the Robusta pods. And we say, okay, and we add it. So like we have a simple YAML, and now that YAML, like there's a pod inside that YAML deployment. And now that YAML has like a templated section for the annotations. Then tomorrow someone comes along and this guy says, okay, I'm running like with Windows nodes in half my cluster. I want Robusta not to run on the Windows nodes. And he doesn't want to do it using like the taints and tolerations. He wants to do it using some other mechanism. So you end up supporting that. So now your Helm chart has those two things. Then someone else comes along and he says, okay, for security reasons, I can't pull from your repo. I copy all the images over to my repo or to like a JFrog repo. I need to control the repo and image tag. So now your beautiful pod YAML or deployment YAML has an extra parameter for that. And as time goes on, you get all these requests and your thing ends up going from Kubernetes YAML to all swirly braces. It's like that old joke about this. You know the old joke about this and the CIA?
Go ahead.
So once the CIA, the Soviets or something wanted to steal like some big confidential thing from the CIA, and they only got like they had all these papers and like paper printouts or something, and they got all the pages of paper except for like the first page. And they open it up and they're looking at the secret code and it's all just closing parentheses because that's how this works. So sometimes I feel like that with Helm. That with Helm, you end up with this like this beautiful YAML, this one beautiful simple YAML that's super readable, and then you end up with just these templates and ifs everywhere. And really, if you look at the core of it, about all those things I said with Windows nodes and ARM nodes and the image registry and everything, all of that is nothing that's related to my application. It's all stuff that's specific to your environment, not to my application. And for stuff like that, the case that I'm going to make is that you don't need a templating engine. What you need is you need overlays. And you need to do something like customize. So I'm not saying don't use Helm. I'm saying use Helm for the application-specific stuff. But for all the weird requests that are specific to your environment, I'm a people pleaser. I'll add it to the Helm chart, okay? I can't help myself. But really, it's something you should be doing with customize.
Yeah, I think that's a fair argument, and there are some tools that allow you to do things like that. Cap or cap controller, you can deploy a Helm chart and add overlays as well, and things like that are really powerful. But I would argue that it's a matter of perspective when it comes to the complexity, right? Certainly from a maintainer's perspective, it can get unwieldy because you're the person who's fulfilling the requests more often than not, right? But from a user's perspective, usually what happens is all of that craziness is sort of like obfuscated inside of the templates themselves, and the values files, which are much more simple and usually well commented with how to use the different parameters. Somebody just goes through, finds the things that they need, and that makes it really flexible for a user when a Helm chart gets crazy like that and starts accommodating a lot of different use cases.
So look, can I share my screen on this?
Sure.
I don't know if this is going to be audio only, or are we going to have video on this?
No, we're going to have video. We're going to see beautiful faces.
So let me share my screen, okay? And am I sharing the right screen? You see here the deployment YAML?
Yep.
Okay. So if we're just looking here at this is from another Helm chart we maintain for KubeWatch. And here's a deployment. And this is more Helm stuff than it is YAML. And the vast majority of everything over here is not even related to this application. Like this is node affinities, right? That's host aliases. Like the vast image pull secrets, right? Like the vast majority of stuff here has nothing to even do with the Helm chart, with the application that's being deployed with Helm. It's all stuff that really has to do with the environment that you're deploying it into.
Yeah, I definitely See, I'm gonna have a hard time disagreeing with you here because I think you and I have similar outlooks on Helm. But I guess let's see the values.yaml file, right? Like going back to what I was saying, in order to use those different pieces in there that were created.
Okay, you can't argue with this, right? This is good. This is elegant. I can't argue with this. I mean, this is fantastic, right? Like I know exactly what it exposes. I know what I can do with it. I might get a little bit lost in here, but I mean, I can live with that.
Yeah. And the other great thing, right, is that in your chart YAML, we have versions. So anytime we update something, we can update our chart version, and that way we can pin our applications at a certain version. We know what we deployed. When it gets updated, we can go ahead and test that new version, make sure that everything works properly. You end up with very predictable outcomes. I'm sorry?
What is Helm really? Is it a package manager for installing third-party software into your cluster, right? And for managing rollbacks and like for managing versions?
Yep.
Or is it templating, like a way to render out YAML based on different templates? Or like it's so many things bundled into one solution.
Yeah, that's one of the reasons that I'm kind of a big fan of simple tools. Like the Carvel suite really appeals to me, right? Because it's like one tool for one thing, and then you end up almost piping them together like you would with Unix commands. The Unix philosophy on software development is pretty awesome, right? Like it prevents tools from becoming really overblown and taking on too much and being hard to maintain. But I think that the Helm I guess list of capabilities right now it's not single purpose actions, but it is tightly coupled actions, right? Like the things that it does, I think first and foremost it really is like sort of a package manager, but it has templating because it allows that flexibility in the deployments. So I think that the scope of what the tool does is probably pretty valid. Separating them, I don't think you'd gain much.
No, it makes sense. It's like you want to do them together. Like even look at Customize, which is like an overlay tool to customize your YAMLs. Mm-hmm. It's packaged into kubectl, which you use that like with kubectl apply because you want to do the two of them together. And like look at it from the perspective of someone who's installing third-party software. You want to customize it and put in these settings. But again, what just bothers me is like, okay, I'm looking here at this. All of this is just the guys at Carvel. Once I did an interview with them, and one of them said that your Helm charts mirror the Kubernetes API. Like your values file ends up mirroring the Kubernetes API. And like this is just a perfect example of that. Like every value that you can expose in the Kubernetes API is like exposed here for the liveness probe. And I don't know.
I think that's a really good point, that pretty much anything that allows interaction with an API tends to fall into that trap over time. So I've made this argument about Terraform modules. When they're publicly accessible, publicly maintained modules, what it ends up doing is allowing access to any API thing, right? So like your VPC, your instances, whatever, right? Like when you go and find a module that deals with that, it allows you to tweak literally anything in the API. And the way that you do that is you end up moving all of those different flags into data structures that you then pass into the module, and your data structure ends up looking really close to what the resource would just look like if you just wrote the darn thing from scratch. And like I'm big in the Salt project open source community as well. Same deal there, right? Like they have open sourced Salt formulas that like deploy applications and things like that. And they try and be really broad. They take on multiple operating systems, anything from like Arch and Debian and Ubuntu and, CentOS or whatever. And in order to deal with all those different scenarios and then deal with all of the application configuration scenarios, things like that, you end up having these large data structures that you have to pass into these things in order to make it work the way that you want to work. And so like I'm a really big fan of opinionated public tooling. And if you want to get crazier than that, then use that as a base and build on it somehow.
Yeah, so let's talk about the alternatives, okay? Can I pitch the alternative that I love? And I'm not going to pitch YTT, though. I think YTT is very cool. But I'm going to pitch something that's built into kubectl and that works well with Helm. So there's YTT. So here's the pattern that I want to see more of, okay? You got a Helm chart, and you just expose the stuff that's specific to your application. So you're not exposing like any node affinities or any of that, right? You're not exposing like anything that really relates to your environment or annotations you want to set or even labels. None of that goes in there. And now just the stuff that's actually specific to the application. Now you go and you deploy, and you want to just run it on the ARM node. So use customize, and customize, people who don't know, like Helm is a template, right? So you're outputting a template, and everything that like gets put in there has to be inside the template. So the template, like the template developer is aware of all the changes you're going to make, and it has to support it, right? The data structure has to support what you want to change. But when you use customize, then the template like has zero awareness. I mean, just the YAML or just the Helm output. And instead you specify like as a patch, what you essentially say in customize is take every single deployment resource or take every pod and add on this annotation or add on this toleration to all of them, right? That's the general concept. I'm hand waving a little bit, but that's the general concept with overlays. You're saying like, take this as a base and now apply this set of patches. And then it shifts the control. It shifts like the burden also on understanding what you want to apply and how to do it from the maintainer of those YAMLs of that Helm chart. It shifts it to the end user who just specifies like a common set of patches for all the stuff in his environment. And then you get to reuse it as well. We like dry, like don't repeat yourself, right? So you get to have a common thing, like for all your applications to a small little patch that you run with a small little customized overlay for all your applications that you use to make sure they don't run on the ARM nodes. So that's the type of thinking I want more. So it's not really don't use Helm, it's use Helm for the templating and application stuff and to install and like as a package manager, but use customize or YTT or something else like that with overlays to do that, to do the environment specific stuff.
I think that's fair. While we're sort of on this topic, we've been talking a lot about like publicly accessible, like open source projects use Helm to package up their applications and make them deployable for folks. What do you think about people using Helm for internal apps?
So internal apps consumed by other teams or internal apps consumed?
Just, one team deploying one app and they think that they need to create a Helm chart in order to deploy this thing because that's the paradigm that they see out in the wild.
Okay, so I'll give really opinionated advice, okay? Start with customize, never start with Helm. Always start with customize and overlays. And then when you need it and you have extra complexity, then spend 1 hour trying in Helm, spend 1 hour trying in YTT, and pick whatever is a better fit for your scenario. For public facing stuff, like I maintain Robusta, right? So we, for people who don't know, we like take Prometheus and then like it sends alerts to Robusta and then you get better alerts in Stack. Like it finds the logs for when there's an alert on a pod. it looks up data that's relevant to your alerts and like tells you why they happened. And we want to make that as easy to install as possible for everyone who has Kubernetes and for everyone who's using Prometheus. So I don't have a choice. I can't use YTT. I'm not going to give you weird instructions. I don't have the privilege.
Yeah.
But for your own internal stuff, look at your options. And I always like to say, like, start with the simplest thing, but that lets you grow beyond that as well. That's not going to lock you in. So starting with customize instead of Helm is usually a really good start. And when you need extra complexity, then either go with Helm or go with something like YTT. But look at your options. I mean, Helm isn't bad. I have one more pet peeve actually about Helm. One thing that drives me absolutely nuts. And this doesn't happen in internal teams. Because internal teams also don't have those issues, like all the issues I mentioned with node affinities and like, right? And like the Helm chart expanding based on your users, you are your user. So they don't have any of those issues. The one thing that drives me crazy about Helm, this is going to sound really weird, is that Helm doesn't understand YAML. It doesn't know what YAML is. And that sounds like a really weird thing to say.
Yeah.
When you look at Helm templates, there's all this weird stuff you do, like you do swirly braces, and then a dash. And what does that dash there have to do with? It has to do with how you eat up white space when you output the template, right?
Yep.
Helm, and you have all these weird places where you have like indent by this much. Helm doesn't understand the YAML. Like the templating engine, it doesn't know what YAML is. It doesn't, so it's just text. It's like, it's rendering out a text template, and it just so happens that that text happens to have YAML in it. But the templating engine itself has no clue about what's valid YAML syntax or not. And it has no clue about, like, it can't control the white space and indentation for you and just do the right thing because it doesn't understand YAML. And that drives me nuts.
Yeah, it's definitely tough when you're developing or maintaining Helm charts. Especially when you end up inside of like loops and things like that. White space becomes very, very important, and it's tough. I mean, like Jinja in the Python world, same deal, right? Like it doesn't understand the things that it's templating because it's just templating text files, right? It's the same thing for Helm.
Exactly. Yeah.
But
YTT does get it. YTT gets YAML.
Yeah, that's what makes it really, really interesting and powerful, right? Like it can do the text templating, but it's built first and foremost as a YAML templater, and understanding the structure and making sure that it's right is like a huge feature for me. I'm a big YTT fanboy, and it's one of the reasons that I'm having a hard time.
It's okay.
Agreeing with you on everything that you say.
You can swap. We could swap. I'll try and defend Helm. I use Helm every day, so I can defend it too. But they're actually the thing, right? Like
we both sort of live on both sides of the fence, right? So it was a coin flip.
But there's one more thing that drives me crazy about Helm too. Now I'm blinking for a second, but there's one more thing. Oh man, that was driving me crazy. Now I'm completely blinking on this. You'll have to edit this part out. There was one more thing I was thinking of that completely drove me mad recently. Oh yeah, okay. So there's one more thing that drives me completely mad about Helm. You can't use values inside values. Like you want to have, so I'll give you an example, okay? We got a bunch of Helm values, and you want to set, let's say, okay, so it's not actually, it's actually hard for me on the spot to come with a good example that's simple and easy to understand. But there are cases in Helm when you want to put a value in your values file, and then you want to refer to that later on in the same values file. And there are always weird hacks that you can do around it, and you can, like in your template, you can refer to both of them. There are all sorts of weird things, but you can't put values inside your Helm values file, and that drives me mad often. Okay, I'll give
Yeah.
you an example. I know the example. Here's a great example for why you need that. Um, you have a Helm chart and it has a dependency. And I encounter this. Okay, so I have a Helm chart, Robusta, and as a dependency, you can store Robusta alongside Prometheus. So you get an all-in-one monitoring solution. And you pass in some Helm value to Robusta. And we want to take that and we want to do, using that, we want to do something for the dependencies we pull in. So we have a dependency on Kubernetes stack if you're enabling it. And we want to do something conditionally. So you use that Robusta value, and then we want to change values in Kubernetes stack, like change 5 different values according to one thing that you passed into Robusta. And we can't do that.
Yeah. There, I think that's true of really any templating language, right? Like they view the values as static input to the actual templating. And that's where all the logic is.
No, but the problem is with dependencies, because it's okay that that within my own values file, I can't refer to my own values. That's okay.
Mm-hmm.
But when I pass values into a dependency chart, I want to be able to do complex stuff based on the values you set on my own chart. Like, okay, let's say I detect that you're running on GKE and I want to disable 5 specific alerts for Kubernetes stack, which we know are super spammy on GKE and like don't mean anything anyway, because they're like monitoring Kubernetes and it's managed. Like you can't do anything about it anyway, right? I can't do that in the normal, convenient way. We work around it. We do hacks so that because we don't want you to get a bunch of spammy alerts out of the box, but it's not convenient to do. What I'd really like to be able to do is to kind of split off the values I'm passing into the dependencies and to be able to use my own values in there and to template that. Does that make sense?
Yeah, absolutely. Well, I think we've probably squeezed the last drops out of this conversation. Thank you, Natan. I think that we had a really good debate on Helm here, and hopefully it helps some folks, understand scenarios where it's a great tool and scenarios where maybe you should be looking at something else. So we'll call it a day here. We hope you enjoyed this spirited debate on Rated. Big thank you to our guest, Natan Yellin, for joining me today. And to our viewers, don't forget to like, share, and subscribe to catch the next thrilling installment of Rated. Until next time, keep exploring new tech and debate all the things.